somewhere above you, past the ceiling, past the clouds, past the reach of any light you've ever seen with your own eyes. The universe is quietly doing what it has always done. Wherever you may be tonight, I invite you to set the day aside for a little while. Find a comfortable place, take a slow breath, and let your mind wander beneath the stars. Tonight, I'd like to tell you a story, not a myth passed down through generations, nor a tale born from imagination, but the greatest true story humanity has ever uncovered. It is the story of how everything began. Every mountain and every ocean, every tree swaying gently in the wind, every star shining in the night sky, every breath you've ever taken, even you quietly listening to these words. All of it shares the same beginning. I've always found that thought deeply comforting. Ever since I was young, the night sky has filled me with wonder. I remember looking up at those distant points of light and asking the same simple questions that people have asked for thousands of years. What are they? How far away are they? And perhaps the greatest question of all, how did any of this begin? For thousands of years, every civilization looked toward the heavens, searching for an answer. The Egyptians, the Greeks, the civilizations of India, China, the Middle East, and the Americas all told different stories. Yet they were united by the very same curiosity. Today, our answers come not only from imagination, but from centuries of careful observation, remarkable discoveries, and the quiet persistence of science. We still don't know everything, and perhaps that's what makes this journey so extraordinary. Tonight, we'll travel nearly 14 billion years into the past, following the clues left behind in ancient starlight, distant galaxies, and the fabric of space itself. So make yourself comfortable, and together, let's begin at the beginning. Imagine for just a moment that you possess a remarkable ability, not the ability to travel across great distances, but to travel backward through time itself. With every passing second, the universe around you grows younger. The sounds of our modern world begin to fade. Cities disappear. Roads vanish. The lights of millions of homes quietly blink out, leaving only darkness and the stars above. We continue drifting backward. Years become decades. Decades become centuries. Civilizations quietly unfold in reverse. Ancient kingdoms rise from their ruins before gently fading into possibility once again. Great ships return to their harbors before they were ever launched. Books close before they are written. Paintings vanish from their canvases. Every human story slowly unwrites itself. Yet our journey has only just begun. We continue farther. The first telescopes disappear. The great observatories of the modern world have not yet been imagined. Galileo has not yet turned his telescope toward Jupiter. Isaac Newton has not yet wondered why apples fall toward the earth. Even the pyramids have not yet risen from the sands. Soon, there are no cities, no civilizations, no people, only wild landscapes stretching beneath unfamiliar skies. The first humans quietly vanish into the distant past. Our own species has not yet appeared. The earth feels strangely peaceful. Millions of years slip away like grains of sand carried by a gentle current. The last mammoths wander once more across frozen plains. The great dinosaurs return. Towering forests echo with footsteps that disappeared 66 million years ago. For a little while, they rule the earth once again. Then, they too are gone. The forests themselves begin to disappear. The continents slowly shift beneath invisible forces, moving no faster than your fingernails grow. An ocean closes, another opens, mountain ranges rise, only to wear away again beneath rain, wind, and time. Earth becomes younger with every passing moment. The first trees have not yet spread across the land. The first flowers have yet to bloom. The first fish are only beginning to explore ancient seas. Continue still farther. Life itself becomes simpler. Multicellular creatures quietly give way to single-celled organisms, drifting through warm oceans beneath a faint young sun. These tiny living cells know nothing of birds, or whales, or forests, or people, yet every living thing that will ever exist already shares these humble ancestors. We continue our journey. Now even life begins to disappear. The oceans evaporate into steam. Our planet glows with rivers of molten rock. The moon circles much closer than it does today, appearing enormous in Earth's sky. Volcanoes shape a world that would be almost unrecognizable to us. And still, we continue backward. The Earth itself dissolves into a swirling disk of dust, rock, and gas surrounding a newborn sun. The familiar blue planet no longer exists. There are no oceans, no mountains, no continents, only countless fragments slowly circling one another, waiting to become worlds. As millions of years quietly unwind, even the sun begins to fade. Its brilliant light softens. Its immense gravity releases the clouds from which it formed. Our entire solar system slowly returns to a vast cloud of hydrogen, helium, and microscopic grains of cosmic dust. The planets are gone. The asteroids are gone. The comets are gone. Only possibility remains. Far above, the Milky Way itself begins to change. The graceful spiral arms that cradle our solar system lose their familiar shape. Stars drift apart. Clusters dissolve. Many of the stars we know tonight have not yet been born. Their light has not yet begun its long journey across the cosmos. The galaxy itself becomes younger, simpler, smaller, and then other galaxies begin disappearing as well. The elegant whirlpools of stars scattered across the observable universe slowly fade into darkness, one after another. They vanish, not because they have been destroyed, but because they have not yet come into existence. Now we have traveled billions of years into the past. There are no galaxies, no stars, no planets, no life. The universe has become a vast ocean of darkness, filled almost entirely with simple hydrogen and helium. It is astonishingly quiet. This period of cosmic history is so calm that astronomers have given it a rather poetic name: the cosmic dark ages. No sunrise has ever occurred. No sunset has ever painted a sky with color. No star has yet ignited to illuminate the darkness. Gravity is working patiently, silently, drawing together enormous clouds of gas that will one day give birth to the first stars. But that day has not yet arrived. Everything feels as though it is waiting for the first spark, waiting for the first dawn, waiting for the universe to awaken. Yet our journey is not finished. We travel farther still. The darkness begins to disappear, not because light has returned, but because even this quiet chapter of cosmic history has not yet begun. The universe grows hotter, denser, smaller. Time itself seems to tighten around us. Eventually, we arrive at a place unlike anything our imaginations were ever meant to experience. No stars, no galaxies, no atoms, no planets, not even empty space as we understand it. Only an unimaginably young universe filled with energy, beyond anything nature has produced since. Here, almost every picture we carry in our minds begins to fail us. Most people imagine this moment as an enormous explosion, a brilliant flash erupting into a vast, empty darkness. It is a powerful image. Hollywood has shown it countless times. Books often describe it that way. Even many illustrations seem to suggest it. But nature tells a far stranger story. There was no empty room waiting for the universe to appear. There was no silent darkness surrounding it. There was no edge beyond which the explosion expanded. Because there was no outside, the universe was not born inside space. Space itself was coming into existence. Imagine drawing tiny dots across the surface of a balloon before it is inflated. As the balloon slowly expands, every dot moves away from every other dot. None of the dots are traveling across the surface. Instead, the surface itself is growing. Our universe behaves in a remarkably similar way. Galaxies are not simply flying through empty space. The space between them has been stretching for billions of years, gently carrying entire galaxies farther apart. It is one of the most beautiful discoveries modern science has ever made. And yet, it leads us to an even deeper mystery. If space itself could have a beginning, then perhaps time could as well. And that is where our journey will continue. Take another slow, comfortable breath. There is no need to hurry. Some stories are best told gently, allowing each idea to settle before the next quietly takes its place. We have arrived at one of the strangest places in all of science, a place where our everyday experience can no longer guide us. After all, every moment of our lives has unfolded inside both space and time. We have never known one without the other. Every birthday, every sunrise, every conversation, every heartbeat, every memory you have ever carried has existed because time has continued moving steadily forward. It feels so natural that we seldom stop to ask what time actually is. Perhaps because it is invisible. We cannot hold it in our hands. We cannot see it flowing like a river. Yet we feel its presence every day. The ticking of a clock, the changing seasons, the silver strands that slowly appear in our hair, the laughter of children becoming the wisdom of old age. Time seems constant, reliable, almost eternal. For centuries, that was exactly how scientists understood it. The great English physicist Sir Isaac Newton imagined time as a perfect cosmic clock. Whether stars exploded in distant galaxies or apples fell from trees here on Earth, time continued at the same steady pace for everyone. It flowed independently of everything else, a universal rhythm that never changed. It was a beautiful idea, simple, elegant, and for more than 200 years, it described the universe remarkably well. Then, in the early years of the 20th century, a quiet young man working in a Swiss patent office began asking questions that would forever change our understanding of reality. His name, of course, was Albert Einstein. He wasn't surrounded by enormous laboratories or powerful telescopes. Much of his work began as thought experiments. He imagined riding alongside a beam of light. He imagined clocks moving through space. He imagined what the universe might look like if we questioned the assumptions everyone else had accepted. His conclusions were astonishing. Time was not fixed. It was flexible. It could stretch. It could slow down. Given the right conditions, it could even pass at different rates for different observers. Today, more than a century later, we know he was right. Astronauts aboard the International Space Station age ever so slightly more slowly than people on Earth. The effect is incredibly small, measured in fractions of a second. Yet it is real. Even the satellites that help our phones calculate directions across cities must constantly account for Einstein's equations. Without those corrections, modern GPS systems would slowly drift farther from their true positions each day. It is remarkable to think that a theory once considered almost unbelievable quietly helps millions of people find their way home. Perhaps the most extraordinary part of Einstein's work was not that he changed our understanding of time. It was that he revealed time and space were never separate to begin with. Instead, they are woven together into a single fabric that physicists call spacetime. Imagine a great sheet stretching across the cosmos. Everything that exists, every star, every galaxy, every planet, every black hole, rests upon this invisible fabric. Mass bends it, gravity shapes it, and time itself follows its curves. This was one of the most revolutionary ideas in the history of science. It transformed the universe from a collection of objects floating through empty space into something far more elegant, a living, dynamic cosmos where space and time dance together. And if space and time are woven together, then perhaps they also share the same beginning. That simple thought changes everything. When people ask, what happened before the Big Bang? They are asking a perfectly reasonable question. After all, every event in our lives has been preceded by another. Yesterday came before today. Morning came before evening. Parents came before children. Cause before effect. Beginning before ending. It feels impossible to imagine anything else. But nature is under no obligation to behave according to our intuition. Imagine standing at the North Pole. Now ask yourself, which direction is north? It sounds like an ordinary question. Yet the moment you arrive at the North Pole, the question quietly loses its meaning. There is no farther north to travel, not because something blocks your path, but because the direction itself no longer exists there. Many cosmologists believe asking what happened before time may be surprisingly similar. If time itself began with the universe, there may have been no earlier moment, no yesterday waiting behind it, no ticking clock counting down toward creation, not because we have failed to discover it, but because there may have been no before at all. That idea is difficult for the human mind to grasp. Our lives are built upon sequences. One moment follows another. Every story has a beginning. Every journey has a first step. Yet the universe may not have begun inside time. Time itself may have begun with the universe. This is where science becomes wonderfully humble. Despite everything humanity has learned, despite the great observatories perched atop mountains, despite spacecraft exploring distant planets, despite powerful telescopes looking nearly 14 billion years into the past, there are still questions we cannot answer. Some physicists suggest our universe may have emerged from an earlier one. Others imagine an endless cycle of universes, expanding and collapsing across unimaginable ages. Still others explore the strange world of quantum physics, where entire universes might arise from fluctuations far beyond everyday experience. These ideas are fascinating. Some are supported by elegant mathematics. Others remain speculative, but none have yet been confirmed, and that is perfectly all right. One of the quiet strengths of science is its willingness to say 3 simple words. We don't know. Those words are not a weakness. They are an invitation to keep wondering, to keep observing, to keep searching beneath the same night sky that inspired generations before us. Every discovery in human history began with someone willing to admit that a mystery still remained. As our journey continues, we are about to reach the very edge of what modern physics can confidently describe. Beyond that frontier lies a moment so unimaginably brief that even Einstein's remarkable theories can no longer guide us. It lasted for only a tiny fraction of a second, a number so small it is almost impossible to comprehend. Physicists call it the Planck time. It lasted approximately 1/10,000,000,000,000,000,000,000,000th of a second. Written mathematically, it is 10 for 3 seconds. Beyond that point, our equations fall silent. Our understanding fades into uncertainty. And yet, somehow, within that almost unimaginably brief instant, the story of everything had already begun. And that is where our journey continues. The universe has brought us as far back as it can. We have traveled beyond the birth of galaxies, beyond the first stars, beyond the formation of atoms, even beyond the moment when light first began its endless journey across the cosmos. Ahead of us lies a frontier unlike any other, not a distant galaxy waiting to be explored, not a hidden planet circling an unfamiliar star, but a boundary in our understanding itself. It is a place where every telescope falls silent, where every spacecraft could go no farther, where even the most beautiful equations humanity has ever written begin to lose their certainty. This is the edge of known physics. Take another slow breath. There is no need to rush through this moment, for although it lasted less than the blink of an eye, it would shape everything that was yet to come. In the previous chapter, we reached what physicists call the Planck time. It lasted for only about 1/10 million trillion trillionth of a second after the universe began. Written another way, it is 10 for 3 seconds. The number itself is almost impossible to imagine. Our everyday lives offer no comparison. A heartbeat lasts about 1 second. The blink of an eye takes perhaps a third of a second. Light, the fastest thing we know, can travel around the Earth more than 7 times in a single second. Yet the Planck time is so unimaginably brief that there are vastly more Planck moments in one ordinary second than there have been seconds since the birth of the universe, nearly 14 billion years ago. It is a reminder that nature operates on scales far beyond our everyday experience. But why is this tiny interval so important? The answer has less to do with time itself and more to do with the limits of human knowledge. The name Planck time honors the German physicist Max Planck. At the dawn of the 20th century, Planck made a discovery that forever changed physics. While studying how hot objects glow, he realized that energy does not always flow in a smooth, continuous stream. Instead, it comes in incredibly tiny packets that we now call quanta. At first, even Planck regarded the idea as a mathematical trick. Yet experiment after experiment revealed that nature truly behaves this way. His work became the first step toward the strange and fascinating world of quantum mechanics. Without Max Planck's discoveries, much of modern technology would never have existed. Lasers, computer chips, magnetic resonance imaging, solar panels, even the tiny sensors inside the cameras we use every day all owe something to ideas that began with his remarkable insight. Yet perhaps his greatest legacy was something far less tangible. He helped reveal that the universe has natural limits, natural scales, measurements beyond which our current understanding begins to fade. Among them is the Planck time, not because time suddenly stopped there, but because our theories can no longer confidently describe what happened earlier. Imagine trying to read a map. At first, every road is clearly marked. Every river has a name. Every mountain is carefully drawn. But as you move toward one forgotten corner, the details become faint. Eventually, the map simply ends. The land may continue. Mountains may still rise beyond its edge. Rivers may still flow. The map is not telling you that nothing exists there, only that it can no longer guide you. Modern physics stands in much the same position. Two extraordinary theories describe our universe with astonishing success. The first is Einstein's general relativity. It explains gravity. It describes the motion of planets, the dance of galaxies, the bending of light around black holes on the largest scales imaginable. It has passed every experimental test we have thrown at it. The second is quantum mechanics. It governs the smallest scales of existence. Atoms, electrons, particles so tiny that trillions could pass unnoticed through your body every second. Quantum mechanics has proven to be one of the most accurate scientific theories ever developed. Its predictions have been confirmed with astonishing precision. Each theory is magnificent. Each has transformed our understanding of reality. Yet, when we attempt to use both at the same time, at the very beginning of the universe, something unexpected happens. They no longer agree. General relativity describes the smooth fabric of space and time. Quantum mechanics reveals a restless world filled with uncertainty and constant fluctuations. Separately, each theory works beautifully. Together, at the earliest instant of the cosmos, they refuse to fit neatly together. It is rather like owning two beautifully crafted maps of the same country. One is perfect for cities. The other is perfect for forests. Yet, when you place them side by side, the roads no longer meet. The rivers no longer align. Both maps are remarkably accurate, yet neither is complete. Somewhere beyond their edges waits a deeper understanding that humanity has not yet discovered. Physicists have spent decades searching for that missing piece. Some hope it will come through string theory. Others explore loop quantum gravity. Still others pursue entirely different ideas that may one day unite Einstein's elegant geometry with the strange probabilities of quantum physics. For now, the answer remains one of the greatest unsolved mysteries in science, and perhaps there is something quietly reassuring about that. Even after centuries of exploration, even after walking upon the moon, even after launching telescopes capable of seeing galaxies billions of light years away, the universe still keeps some of its oldest secrets. It reminds us that discovery is not a destination. It is a journey. Every answer becomes the beginning of another question. Every mystery solved reveals another waiting patiently beyond. If we could somehow witness the universe during this earliest instant, we would find nothing familiar. No stars, no planets, no atoms, not even the particles that will one day build those things. Instead, the universe would be filled with energy so immense that the distinction between matter and energy had not yet emerged in the way we understand today. Temperatures were almost beyond comprehension. Physicists estimate they exceeded 10 to the 32nd power degrees, a number so vast that writing it in full would fill nearly an entire line with zeros. At such unimaginable energies, the very laws of nature may have behaved differently from those we observe today. It is here, at this silent frontier, that every pathway we have followed through science begins to disappear into mist. And yet, out of that mystery, something extraordinary was about to happen. The young universe, smaller than we can truly picture, was about to expand with astonishing speed, a moment that would forever shape the cosmos, and with it, the story of everything. Imagine holding a tiny balloon in your hands. Before a single breath enters it, every point drawn upon its surface rests close together. Then, almost instantly, the balloon begins to expand. The dots do not race across the rubber. Instead, the rubber itself stretches, gently carrying every point away from every other. Our universe experienced something that, in spirit, is surprisingly similar, only far more extraordinary. In the earliest fraction of a second, the universe is thought to have undergone an event known as cosmic inflation. The name sounds gentle, almost peaceful, yet it describes one of the most dramatic transformations nature has ever performed. Space itself expanded at an astonishing rate, not because galaxies were flying through the universe. There were no galaxies. Not because stars were rushing apart. There were no stars. There were not even atoms. It was space itself that suddenly grew. For many years, this rapid expansion puzzled scientists. Why does the universe appear so smooth in every direction? Why is the geometry of space so remarkably flat on the largest scales? Why do distant regions of the cosmos, separated by unimaginable distances, look so similar? In the late 20th century, the American physicist Alan Guth proposed a bold answer. Perhaps in its earliest instant, the universe expanded unimaginably fast. An almost inconceivably tiny region suddenly became vastly larger, smoothing out irregularities much as a wrinkle disappears when a sheet is gently pulled taut. The idea was elegant. Over time, other physicists refined and expanded it, and today inflation remains one of the leading explanations for the universe we observe. Although researchers continue to investigate its details, many observations are remarkably consistent with this picture. What makes inflation so extraordinary is not simply its speed. It is the scale. If an ordinary object behaved in a similar way, it would be as though something smaller than a single atom suddenly became larger than an entire galaxy before you could even begin to notice it. Our minds are not built to picture such extremes, and perhaps they were never meant to be. Yet the universe has never been limited by the boundaries of human imagination. As space expanded, something subtle and beautiful was happening beneath the surface. The newborn cosmos was not perfectly uniform. Tiny quantum fluctuations, minute variations arising naturally from the strange rules of quantum mechanics, were present even then. Normally, these fluctuations exist only on unimaginably small scales. They appear and disappear almost instantly, but inflation changed their destiny. As space expanded, those microscopic ripples were stretched across enormous distances. The smallest whispers of the quantum world became the faint patterns from which future galaxies would eventually grow. It is a breathtaking thought. The largest structures in the observable universe may trace their origins to fluctuations so tiny that they belonged to the mysterious realm of quantum physics. In a sense, the grand architecture of the cosmos began as the gentlest of imperfections. Not perfect uniformity, but tiny differences that gravity would patiently nurture over billions of years. Every galaxy, every cluster of stars, every planet, every ocean, every living creature even every person who has ever looked upward in wonder. All may owe their existence to those almost unimaginably small variations present in the universe's earliest moments. Sometimes the smallest beginnings truly do shape the greatest stories. Our story continues only the smallest fraction of a second after the universe took its first great breath. The unimaginable expansion of cosmic inflation had come to an end. The universe was still astonishingly young, still unimaginably hot, still smaller than anything our minds can comfortably picture. And yet, it was no longer the violent mystery that lay beyond the blank time. For the very first time, the laws of physics that scientists understand today could begin to describe what was happening. The universe had entered an age where its story could finally be read. Not perfectly. There are still mysteries waiting to be solved, but enough clues remain for us to piece together the opening moments of everything we know. Imagine standing beside a roaring waterfall. The rushing water is so powerful that individual droplets disappear into a single white torrent. But as the river continues downstream, it begins to slow. The spray settles. Tiny droplets become visible. Patterns begin to emerge. The early universe behaved in much the same way. As it expanded, it also cooled, only by an incredibly small amount at first. Yet even the slightest drop in temperature allowed something remarkable to happen. Energy, pure energy, could begin transforming into matter. More than a century ago, Albert Einstein revealed one of the most famous relationships in all of science. You may know it as E equals mc squared. It is a short equation, just 3 symbols and a number. Yet within it lies one of the deepest truths about our universe. Matter and energy are not entirely different things. They are, in a sense, 2 forms of the same reality. Under the right conditions, matter can become energy. The sun does this every second, transforming a tiny amount of its mass into the sunlight that warms our world. But the opposite is also true. When enough energy exists in one place, it can become matter. The young universe possessed more than enough energy. As temperatures slowly fell from their unimaginable extremes, that vast ocean of energy began giving birth to the first particles. Not atoms, not molecules, not even protons. Something smaller, far smaller, the first building blocks of matter. Among them were particles known as quarks. If atoms are like tiny solar systems, and protons are one of the objects at their center, then quarks are the ingredients from which those protons are made. They are among the most fundamental particles we know. Nature appears to build much of the visible universe from them. Yet quarks are unlike anything we encounter in everyday life. No one has ever picked up a single quark. No one ever will. The laws of physics bind them together with extraordinary strength. Try to pull 2 quarks apart, and the force between them grows stronger, almost as though nature refuses to let them exist alone. Holding these tiny particles together are other remarkable particles called gluons. The name is wonderfully descriptive. Much like glue holds pieces of wood together, gluons carry the force that binds quarks into larger particles. Invisible, constant, unwavering. Together, quarks and gluons filled the newborn universe. For a brief period, everything existed as an unimaginably hot sea of these tiny particles, moving with incredible energy. There were no stars, no planets, no galaxies waiting in the darkness. Only this brilliant, restless ocean from which everything else would eventually emerge. It is extraordinary to think that every mountain on Earth, every tree, every ocean, every person who has ever lived can trace their existence back to this simple beginning. Not to a world, not to a star, but to tiny particles dancing through an unimaginably young universe. The cosmos was taking its first steps. Slowly, patiently, one law of physics at a time. And before long, those tiny quarks would begin joining together, forming the first protons and neutrons, the very first ingredients from which atoms, and eventually stars, planets, and life itself would one day be made. The universe continued to expand, and with every passing moment, it continued to cool. To us, cooling is something gentle. A cup of tea left beside a window, the evening air after a warm summer afternoon, the glowing embers of a campfire slowly fading into ash. But in the early universe, cooling meant something far more profound. It meant that chaos was beginning to give way to order. The restless sea of quarks that had filled the cosmos could no longer remain as it was. As temperatures fell below an extraordinary threshold, quarks began to join together, bound tightly by the strong nuclear force. For the first time in cosmic history, stable particles began to appear. 3 quarks combined to form a proton. 3 more, arranged in a slightly different way, formed a neutron. These humble particles would become the foundation of every atom that has ever existed. Every drop of water, every grain of sand, every tree, every planet, even every cell within your own body, would one day owe its existence to these first tiny gatherings of quarks. The universe was only fractions of a second old, yet already the blueprint for everything that would follow was quietly taking shape. As the first seconds passed, protons and neutrons rushed through the young universe at incredible speeds, colliding, separating, meeting once again. The cosmos was still unimaginably hot, hotter than the core of any star that would ever exist. Under these extraordinary conditions, particles could not remain together for very long. Every time 2 joined, violent collisions often tore them apart again. It was a universe still searching for balance. Then, after about 1 second, another quiet change unfolded. The temperature had fallen enough for many of these particles to survive their encounters. The universe had become just stable enough for construction to begin. If the first fraction of a second had been the laying of a foundation, this was the moment the first walls began to rise. During the next few minutes, one of the most important events in all of cosmic history took place. Physicists call it Big Bang nucleosynthesis. The name may sound intimidating, but the idea itself is beautifully simple. Tiny particles were beginning to assemble into the first atomic nuclei. protons found neutrons. They joined together, held by the strongest force in nature. Most remained alone, becoming the nuclei of future hydrogen atoms. Others combined into helium. A very small number became lithium. And then, quite unexpectedly, the process almost completely stopped. At first, this seems rather surprising. If the universe had begun building atoms, why didn't it continue creating carbon, or oxygen, or iron? Why not every element we know today? The answer lies in time. The early universe was changing incredibly quickly. Expansion continued. Temperatures kept falling. Within only a few minutes, conditions had become too cool for further nuclear reactions to continue efficiently. The great cosmic furnace that had forged the first nuclei quietly faded. Its work was complete. When the universe emerged from those first few minutes, it consisted of roughly 75% hydrogen and 25% helium, with only the faintest trace of lithium. Nothing more. No carbon, no oxygen, no nitrogen, no calcium for bones, no iron for blood, no gold, no silver, none of the elements that would one day shape planets, forests, oceans, or living creatures yet existed. Those would have to wait for another generation of cosmic builders. The stars, in a way, the universe had gathered its ingredients, but it had not yet begun cooking the meal. It was a remarkably simple cosmos, and perhaps in its simplicity, there was a quiet kind of beauty. Hydrogen, helium, light, energy, space, time, everything else still lay hidden in the future. Yet despite all this progress, the universe remained strangely blind. Light filled every corner of space. Photons were everywhere. The young cosmos glowed with a brilliance beyond imagination. And yet, if you could somehow have stood there, you would have seen almost nothing at all. Because the light itself could not travel freely, every photon that tried to move forward was almost immediately scattered by countless free electrons racing through the universe. It was like trying to shine a flashlight through the thickest fog imaginable. The light existed. It simply could not escape. For hundreds of thousands of years, the universe would remain wrapped in this brilliant, glowing mist, a cosmos filled with light, waiting patiently for the day it could finally be seen. For nearly 380,000 years, the universe had glowed like a brilliant, endless fog. Light filled every corner of space, yet no light could travel very far. Every photon was scattered again, and again, and again, until finally, the universe cooled enough for a remarkable transformation. Electrons found their partners. They joined with the tiny atomic nuclei that had formed long before. For the first time, complete atoms came into existence, mostly hydrogen, some helium, a whisper of lithium, almost nothing else. And in that quiet moment, something extraordinary happened. The fog lifted. The countless photons that had spent hundreds of thousands of years trapped within the young universe were suddenly free. They began a journey that continues even today. Some of that ancient light is still crossing the cosmos, finally reaching the telescopes we have built on our small blue world. It is the oldest light we will ever see, a silent photograph of the infant universe, one that has traveled for nearly 14 billion years, simply to tell us where our story began. Then, the light moved on. The universe grew darker, not because the light disappeared. Far from it, those ancient photons continued racing across space at the speed of light, but they slowly stretched as the universe expanded, becoming longer and colder, until their glow slipped beyond the range of human eyes. The cosmos entered a new chapter, one unlike any before it. Imagine standing beneath a perfectly clear night sky. No moon, no city lights, no distant villages, only darkness stretching from one horizon to the other. Now imagine removing every visible star, every galaxy, every glowing nebula, every planet. Leave only empty blackness. Even that would still be brighter than the universe was during this age. Astronomers call it the cosmic dark ages. I prefer to think of it as the universe holding its breath. Nothing dramatic was happening. There were no exploding stars, no swirling galaxies, no planets slowly forming around newborn suns, no life wondering where it had come from. Only silence, only darkness, only patience. Yet beneath that silence, gravity had already begun its quiet work. Gravity is unlike any other force in nature. It does not shout. It does not rush. It simply waits. Given enough time, gravity can gather scattered grains of dust into planets, planets into solar systems, stars into galaxies, galaxies into immense clusters spanning millions of light years. It is perhaps the most patient sculptor the universe has ever known. During these long dark ages, gravity began gently pulling together enormous clouds of hydrogen and helium. The process was almost unimaginably slow. Millions of years passed, then tens of millions. Nothing seemed to change. If you could have watched the universe during this time, you might have believed nothing would ever happen again. But nature often works most beautifully when it works most quietly, hidden within the darkness. The first chapters of every future galaxy were already being written. The universe had not fallen asleep. It was simply preparing for its first sunrise. If we could have wandered through the universe during those ancient ages, we might have believed we were witnessing an endless emptiness. There were no familiar constellations overhead, no Milky Way stretching across the heavens, no distant galaxies glowing like islands of light, only vast clouds of hydrogen and helium, drifting almost silently through expanding space. Yet appearances can be wonderfully deceptive. The universe was far from empty. It was quietly building the foundations of everything that was still to come. Imagine watching a snowfall on a calm winter evening. At first, each snowflake seems to fall alone, but over time, tiny drifts begin to form. Those drifts become hills. The hills become deep blankets of snow, shaped not by sudden change, but by countless small moments working together. Gravity behaves in much the same way. It does not require urgency. It requires only time. And the universe had plenty of time. Over millions of years, the faintest differences in density began to matter. Some regions of space contained ever so slightly more hydrogen than others. The difference was almost impossibly small. If you had compared one region with another, you might have found only a tiny extra amount of matter among millions of particles. Yet gravity noticed. Where there was just a little more matter, there was just a little more gravity. And where gravity became slightly stronger, it pulled in still more matter. Little by little, almost imperceptibly, small clouds became larger ones. Larger clouds became enormous rivers of gas, stretching across unimaginable distances. Modern astronomers now call this immense structure the cosmic web. It is one of the most breathtaking discoveries of recent decades. The universe is not arranged randomly. Galaxies are woven together like glowing dewdrops, resting upon invisible strands of silk. Between those strands lie enormous voids, regions so vast and empty that a beam of light can travel for hundreds of millions of years before encountering another galaxy. It is difficult to picture, yet on the grandest scales, the universe resembles a living network far more than a scattered collection of stars. Curiously, much of this great architecture was guided by something we cannot see at all. Scientists call it dark matter. Despite the name, dark matter is not simply ordinary matter hiding in the shadows. It neither shines nor reflects light. No telescope has ever photographed it directly, and yet everywhere astronomers look, they find unmistakable evidence that something unseen is shaping the cosmos. Galaxies rotate too quickly to be held together by visible matter alone. Clusters of galaxies bend light more strongly than their stars can account for. Again and again, the evidence points toward an invisible companion, outweighing the ordinary matter that makes up stars, planets, oceans, and ourselves. Even today, we do not know exactly what dark matter is. Some of the brightest scientific minds on Earth continue searching for the answer, but whatever its true nature may be, it appears to have played a vital role during these silent ages. Like an unseen gardener preparing fertile soil long before the first flower blooms, dark matter helped gather ordinary gas into places where gravity could continue its patient work. The great clouds grew heavier, denser, warmer, their own gravity becoming stronger with every passing million years. The universe had been waiting a very long time for this moment. At last, hidden deep within one of those enormous clouds, gravity was about to achieve something it had never done before. The darkness that had filled the cosmos for hundreds of millions of years was nearing its end. Somewhere, in a place no eye had ever seen, the very first star was preparing to ignite, and with it, the universe would witness its first sunrise. For hundreds of millions of years, the universe had known only darkness, not the darkness of an empty room, nor the darkness beneath a moonless sky. This was a darkness unlike anything we have ever experienced. There were no stars to cast their gentle light, no galaxies glowing across unimaginable distances. No planets circling quiet suns, only vast clouds of hydrogen and helium, drifting silently through an ever-expanding cosmos. Yet deep within those ancient clouds, gravity had never stopped its patient work. It pulled, slowly, relentlessly, without rest. As millions of years passed, the clouds became denser. The atoms found themselves drawn ever closer together. The weight of the cloud pressed inward from every direction. The center grew hotter, then hotter still. Imagine placing your hands around a snowball and gently squeezing. The harder you press, the smaller and denser it becomes. Now imagine doing the same with a cloud thousands of times larger than our solar system. As gravity compressed the cloud, something extraordinary began to happen. Its temperature climbed into the millions of degrees. Atoms collided with tremendous force. The once quiet cloud had become a cosmic furnace. For a very long time, gravity seemed unstoppable. Everything was falling inward. Everything was collapsing toward the center. Then, in one breathtaking moment, nature discovered balance. Deep inside the heart of that collapsing cloud, hydrogen nuclei began colliding so violently that they fused together. Two became one. A tiny fraction of their mass disappeared, but it was not truly lost. As Albert Einstein had shown many years later, a small amount of mass could become an enormous amount of energy. For the very first time in the history of the universe, nuclear fusion had begun. A star was born. It is difficult to overstate how remarkable this moment was. Until now, the universe had been illuminated only by the fading glow left over from the Big Bang. That ancient light continued to travel through space, growing colder with every passing age. But this was something entirely different. This was fresh light, light born inside a living star. The first sunrise the universe had ever known. Its light spread outward across the darkness. For millions of light years, there had been only silence and shadow. Now, for the first time, darkness met dawn. One lonely star shone where none had shone before. It would not remain lonely for long. Around the universe, countless other clouds had been following the same patient path. Gravity had been working everywhere. One by one, more stars ignited. Tiny islands of light appeared across the immense black ocean of space. The long cosmic night was beginning to end. These first stars, however, were unlike the stars we see in the sky tonight. Our sun is calm, steady, middle-aged by stellar standards. It has burned peacefully for more than 4.5 billion years and will continue to shine for billions more. The first stars lived very different lives, born in a universe made almost entirely of hydrogen and helium. They grew to astonishing sizes. Many astronomers believe they were hundreds of times more massive than our own sun. They burned with incredible brilliance, but such brilliance came at a price. Like candles burning fiercely in a strong wind, they consumed their fuel at an astonishing rate. Their lives were measured not in billions of years, but in only a few million. Brief, brilliant, and destined to change the universe forever. Those first stars burned with a brilliance the universe had never witnessed before. Their light raced outward across the darkness, traveling farther every second, illuminating regions of space that had never before known a sunrise. For the first time since the cosmos began, the universe was no longer a place of endless night. It had become a place of beginnings. But these magnificent stars carried another purpose, perhaps an even greater one. Light was only part of their gift. Deep within their blazing hearts, something extraordinary was taking place. Every second, unimaginable pressures squeezed atomic nuclei together. Hydrogen fused into helium. Helium fused into carbon. As the stars aged, their immense gravity forced the process to continue. Carbon became oxygen. Oxygen became neon. Neon became magnesium. Magnesium became silicon. Layer upon layer, the interiors of these giant stars became like the rings of a great cosmic onion. Each shell forging a new element beneath temperatures so extreme they are difficult to comprehend. It is here that the universe began writing the chemistry of life. The oxygen you breathe, the calcium in your bones, the carbon that forms every cell in your body. All of these elements were born inside stars. The universe had finally found its great factories. For millions of years, these stellar furnaces worked without rest, quietly enriching the cosmos with new forms of matter. Yet nothing in nature lasts forever. Even stars must one day face the end of their journey. For the first stars, that end arrived quickly, having consumed their fuel at a tremendous rate. Their cores slowly filled with heavier and heavier elements. Eventually, they reached iron. Iron is unlike the elements before it. Fusing hydrogen releases energy. So does helium. Even carbon and oxygen can continue the chain. But iron is different. Trying to fuse iron requires energy, rather than releasing it. It is a dead end, a wall that even the greatest stars cannot overcome. Once a massive star builds an iron core, the balance that has held it together for millions of years begins to fail. Gravity, which had patiently created the star in the first place, returns to reclaim it. In less than a heartbeat on the cosmic timescale, the core collapses inward. Matter falls at astonishing speeds. Temperatures soar. The pressure becomes almost beyond imagination. Then, the universe witnesses one of its most spectacular events. The star explodes. Astronomers call this a supernova. The name hardly captures its grandeur. For a brief time, a single exploding star can outshine an entire galaxy, containing hundreds of billions of stars. Its light races across the universe like a final farewell. Its shockwave tears through surrounding clouds of gas, carrying newly forged elements into the darkness. And something even more remarkable happens during those final moments. The tremendous energy of the explosion creates elements that the star could never have made during its lifetime. Gold, silver, uranium, many of the rare elements we treasure here on Earth are born only in these violent deaths. It is a beautiful paradox. Creation arriving through destruction. The ending of one story becoming the beginning of countless others. When astronomer Carl Sagan famously said, We are made of star stuff. He was not speaking poetically. He was speaking quite literally. Every atom of carbon in your muscles, every atom of oxygen in your lungs, every atom of calcium in your teeth, every atom of iron flowing through your blood was forged inside ancient stars that lived and died billions of years before our sun was ever born. Some of those atoms have traveled across the Milky Way for unimaginable lengths of time. They became part of vast clouds drifting between the stars. Those clouds would one day collapse again under gravity's patient pull. From them, new generations of stars would emerge. Around those younger stars, planets would slowly take shape. On at least one of those planets, oceans would form. Life would begin. Creatures would evolve. And one day, a curious species would look upward into the night sky and wonder where it had come from. The answer had been shining above them all along. Every star they admired, every constellation they named, was a reminder of their own ancient ancestry. The first stars had lived only briefly, yet their legacy would outlast them by billions of years. Without their light, the universe would have remained dark. Without their sacrifice, there would be no rocky worlds, no forests, no mountains, no seas, no living creatures asking timeless questions beneath a quiet evening sky. The first stars were more than lights in the darkness. They were the universe's first storytellers, and from the ashes they left behind, a new chapter was about to begin. The age of galaxies. The universe had changed forever. Where there had once been only darkness, there was now light. Where there had once been only hydrogen and helium, there were now dozens of new elements, scattered across the cosmos by the deaths of the first stars. It is tempting to imagine that the universe had finally reached its mature form, that the great story of creation was complete. But in truth, it was only beginning. The first stars were not destined to remain alone. Like travelers gathering around a warm fire on a cold evening, gravity slowly began drawing them together, one by one, then hundreds, then thousands, then millions. Across the universe, enormous families of stars began to assemble. These would become the first galaxies. Imagine standing upon a quiet hill on a clear night. The stars above appear scattered, almost at random. Yet appearances can be deceiving. The universe is remarkably organized. Gravity has spent billions of years arranging stars into magnificent structures of astonishing beauty. Some galaxies resemble graceful spirals, their luminous arms winding gently around brilliant centers like celestial pinwheels. Others are smooth and rounded, appearing almost like enormous glowing lanterns suspended in the darkness. Still others are irregular, shaped by ancient collisions and gravitational encounters that occurred over countless millions of years. Every galaxy tells a different story. Everyone has lived a different life. Our own home, the Milky Way, is one such galaxy. Tonight, if you find yourself beneath a truly dark sky, far from the lights of towns and cities, you may see a pale band stretching gently overhead. For thousands of years, people wondered what that faint river of light might be. Ancient cultures imagined it as a heavenly road, a sacred river, a pathway walked by gods and ancestors. The truth turned out to be even more extraordinary. That soft glow is not a cloud, nor a ribbon of mist. It is the combined light of hundreds of billions of distant stars, so numerous and so far away that they blend together into a gentle river of light. Every star you can easily see with your eyes belongs to our own small neighborhood within this immense galaxy. And beyond them, there are hundreds of billions more. It is a humbling thought. If every grain of sand on a beach represented a single star, our galaxy alone would still contain enough stars to fill countless beaches across the Earth. And yet the Milky Way is only one galaxy among hundreds of billions that populate the observable universe. The scale is almost beyond imagination. But galaxies are far more than collections of stars. They are living ecosystems of the cosmos. Within them, stars are continually being born inside vast clouds of gas. Others quietly grow old. Some swell into enormous red giants. Some collapse into white dwarfs. The most massive end their lives in brilliant supernova explosions, enriching their surroundings with new elements that will someday become future stars and planets. Galaxies breathe, in a sense, not with lungs, but through an endless cycle of birth, life, death, and renewal. For billions of years, this quiet rhythm has continued. Stars creating the ingredients for new stars, generation after generation, like forests renewing themselves after every season. Every atom around us has been part of this great cycle. The iron in your blood, the calcium in your bones, the oxygen in every breath. Each has lived many lives before becoming part of you. Long before Earth existed, these atoms journeyed through ancient stars, crossed enormous clouds of interstellar space, and drifted through galaxies that were already old before our sun had even formed. The universe wastes very little. It simply reshapes, recycles, renews. And while galaxies were becoming the great cities of the cosmos, one quiet corner of one ordinary galaxy was preparing for a story unlike any that had come before, a story that would eventually lead to oceans, mountains, life, and a small blue world whose inhabitants would one day wonder how it all began. That story begins with the birth of an ordinary star, one we simply call the Sun. As our journey continues, we find ourselves surrounded by something both familiar and mysterious. The stars still shine above us. Galaxies still drift through the darkness, and the great tapestry of the universe stretches farther than imagination can reach. Yet everything we have explored so far, every glowing nebula, every brilliant star, every distant galaxy, makes up only a small fraction of what truly exists. It is a quiet thought. Everything your eyes have ever seen, from the sunlight warming the earth to the faint glow of the Milky Way crossing a clear night sky, represents only a tiny portion of the cosmos, like the tip of an enormous iceberg floating upon a calm ocean. The visible universe hides something far larger beneath the surface. For centuries, Humanity believed that if something could not be seen, it probably was not there. Our understanding of the universe depended almost entirely on light. We trusted our eyes and later our telescopes to reveal reality. But the universe had been keeping a secret. As astronomers built larger telescopes and looked deeper into space, they noticed something strange. Galaxies were spinning much faster than they should have been, according to everything they understood about gravity. These galaxies ought to have slowly pulled themselves apart. Their stars should have drifted away into the darkness long ago, and yet they remained together. It was as though an invisible hand was quietly holding each galaxy in place. No telescope could see it. No camera could capture it. No beam of light reflected from it. Still, its presence could be felt through gravity alone. Scientists eventually gave this invisible companion a simple name: dark matter. Despite the mysterious title, dark matter is not believed to be dark in the ordinary sense. It is simply invisible. It neither shines nor reflects light, making it impossible to observe directly. Instead, we discover it by watching how it gently influences everything around it. Imagine standing beside a still lake at night. A soft mist covers the water, hiding everything beneath the surface. You cannot see the fish swimming below, but gentle ripples spread across the lake. From those ripples alone, you know something unseen is moving through the water. Dark matter is much the same. Although invisible, it quietly shapes the universe through gravity, guiding stars around galaxies, and helping enormous clusters remain bound together across unimaginable distances. Today, astronomers estimate that all the stars, planets, moons, oceans, mountains, and even every living creature account for only about 5% of the universe. The remaining 95% belongs almost entirely to things we cannot yet fully understand. It is a remarkable reminder that the universe is still filled with unanswered questions, even after centuries of observation, discovery, and exploration. We are only beginning to understand the grand story unfolding around us. Perhaps that is one of the most beautiful truths in all of science. The more we learn, the more the universe gently reminds us how much remains hidden in the quiet darkness beyond the stars. If dark matter quietly holds galaxies together, then there must be something even greater hidden within the vastness of space. Imagine floating far beyond the Milky Way, looking down upon the universe from an impossible distance. At first, you might expect to see galaxies scattered randomly across the darkness, like grains of sand tossed across a beach. But that is not what astronomers have discovered. Instead, the universe resembles an enormous cosmic web. Across billions of light years, galaxies gather into long, delicate filaments that stretch through space like glowing threads woven into an invisible tapestry. Between these immense structures lie vast, empty regions known as cosmic voids, places so enormous that a beam of light could travel for hundreds of millions of years before reaching another galaxy. It is one of the largest patterns ever found in nature, yet the web itself cannot be seen. What we observe are only the tiny points of light decorating its surface. The hidden framework beneath it is believed to be made largely of dark matter, whose gentle gravity slowly guided ordinary matter into these magnificent structures over billions of years. Without this unseen foundation, the universe might never have become the place we know today. Galaxies may never have gathered. Stars may never have formed. Planets like our own Earth may never have existed. Every peaceful night sky is, in some quiet way, shaped by something we have never directly seen. And then, as if the universe wished to deepen the mystery even further, astronomers uncovered another surprise. Not only is the universe filled with invisible matter, it is also expanding faster and faster. For many years, scientists expected gravity to slow the expansion that began with the Big Bang. It seemed reasonable. Gravity pulls objects together. Surely, over enough time, the universe would gradually ease its outward journey. Instead, observations revealed the opposite. Distant galaxies were drifting away from one another at an ever-increasing pace. Something unseen appeared to be gently pushing space itself outward. This mysterious influence became known as dark energy. Unlike dark matter, which gathers and holds structures together through gravity, dark energy seems to do almost the opposite. It quietly stretches the fabric of the universe, allowing galaxies to drift farther apart with each passing billion years. Even today, no one knows exactly what dark energy is. It may be a property of empty space itself. It may be something entirely new that humanity has not yet discovered. For now, it remains one of the greatest mysteries in modern science. It is comforting, in a way, to know that the universe still keeps its secrets. We often imagine science as a collection of answers, carefully placed upon library shelves, waiting to be read. But science is equally a journey of questions. Each discovery opens another door. Each answer reveals another mystery, waiting quietly beyond. Perhaps that is why the night sky continues to inspire such wonder. Every star we see is only part of the story. Around it exists an invisible universe, silently shaping galaxies, guiding gravity, and expanding the cosmos across unimaginable distances. As we continue our gentle journey through time and space, we carry with us a quiet reminder. Not everything that is real can be seen. Some of the greatest forces in existence leave no light behind them. They reveal themselves only through their quiet influence, patiently shaping the universe while remaining hidden in the darkness. And somewhere, beyond everything we can currently understand, countless more mysteries are waiting for curious minds to discover. For tonight, however, those mysteries can rest peacefully among the stars. As our own journey continues onward through the endless cosmos, our journey has carried us across billions of years. We have watched the first stars ignite. We have witnessed galaxies gathering like great cities across the expanding universe. The cosmos has become a place of breathtaking beauty. Yet among its hundreds of billions of galaxies, one is about to become home, not because it is the largest, not because it is the brightest, but because somewhere within its graceful spiral arms, a quiet story was beginning, a story that would eventually lead to every mountain, every ocean, every living creature, and every person who has ever gazed upward in wonder. Our home lies within the Milky Way, a spiral galaxy stretching across nearly 100,000 light years, containing perhaps 200 billion stars. From a distance, it would appear as a magnificent whirlpool of light, its elegant arms slowly turning through the darkness over hundreds of millions of years. Yet, if you could somehow drift into one of those spiral arms several billion years ago, you would find no sign of our solar system. No Earth, no moon, no sun, only an enormous cloud of gas and dust floating quietly among countless other clouds. At first glance, it would seem unremarkable. Cold, dark, almost invisible. But appearances can be wonderfully misleading. These vast clouds are known as molecular clouds. Some stretch for hundreds of light years. They are among the coldest places in the universe. So cold that temperatures can fall below minus 250 degrees Celsius. In that deep cold, atoms move slowly. Simple molecules begin to form. Hydrogen becomes molecular hydrogen. Tiny grains of carbon and silicates drift through the darkness. The cloud appears lifeless, yet hidden within it are the ingredients for future stars, and perhaps future life. For millions of years, this cloud drifted almost undisturbed. The stars around it continued their ancient dance. Galaxies slowly rotated. Time passed with extraordinary patience. Then, something happened. Astronomers are not entirely certain what the trigger was. Perhaps a nearby supernova sent a powerful shock wave racing through the cloud. Perhaps two clouds gently collided, or perhaps gravity, having quietly gathered matter for millions of years, finally reached a tipping point. Whatever the cause, the cloud began to collapse. Not all at once, not violently, almost gracefully. Gravity slowly drew billions upon billions of tons of gas inward. As the cloud shrank, it began to rotate. At first, the motion was almost imperceptible, but as the cloud became smaller, its rotation steadily increased. You have probably seen something similar. A figure skater begins a graceful spin with arms stretched wide. Then, as the skater pulls those arms inward, the spin becomes faster and faster. The same principle was unfolding here on a scale almost beyond imagination. The cloud continued collapsing. Its center became denser, warmer, brighter. The surrounding gas flattened into a great spinning disk, stretching for billions of kilometers. This disk would become the nursery of our solar system. Tiny grains of dust drifted gently within it. At first, they were no larger than grains of smoke. Then they touched, stuck together, separated, met again. Slowly, patiently, nature was beginning one of its favorite processes, building great things from incredibly small beginnings. At the center of the cloud, pressure continued to rise. More gas fell inward. The temperature climbed from hundreds of degrees to thousands, then millions. The growing sphere had not yet become a true star. Astronomers call this stage a protostar. It shone faintly, not because nuclear fusion had begun, but because gravity itself was releasing enormous amounts of energy as the cloud continued collapsing. It was, in a sense, a star still waiting to be born. Around it, the great disk of dust and gas continued turning silently. Within that disk floated tiny particles carrying a remarkable history. Some carbon atoms had once been forged inside stars that died billions of years earlier. The iron drifting through the cloud had survived ancient supernova explosions. Even the oxygen that would one day become Earth's oceans had already traveled an unimaginable journey across the Milky Way. Nothing here was truly new. The universe was recycling its oldest treasures. The deaths of long-forgotten stars were becoming the birth of another. And this new star, though completely ordinary by the standards of the cosmos, would become extraordinary to us because every sunrise you have ever seen, every warm summer afternoon, every green leaf catching the light, every heartbeat sustained by the energy of food, can trace its existence back to what happened next, deep within the heart of the young protostar. The temperature was climbing toward a magical threshold, 10 million degrees. Soon, gravity would meet a force powerful enough to push back. The universe was about to light another star, one that, billions of years later, would simply be called the Sun. For millions of years, gravity had been quietly gathering the young sun together. With every passing moment, the pressure deep within its heart continued to rise. The temperature climbed higher and higher. 1 million degrees, 3 million, 5 million. The numbers are almost beyond imagination. Nothing on Earth has ever naturally reached such extremes. Even the hottest volcano, the fiercest wildfire, or the brightest bolt of lightning would seem cold by comparison. Then, at last, the center of the young protostar crossed a remarkable threshold, roughly 10 million degrees. At that moment, the hydrogen nuclei deep within its core were moving so quickly that, despite their natural electrical repulsion, they could collide with enough force to overcome it. They fused together, just as the first stars had done billions of years before. Nuclear fusion had begun. Our sun was born. In an instant, a new balance emerged. For millions of years, gravity had pulled relentlessly inward. Now another force answered back. The enormous energy released by fusion pushed outward. The two forces reached a delicate equilibrium. Gravity compressed. Fusion resisted. Neither side won completely. Instead, they settled into a quiet partnership that has endured for nearly 4.5 billion years. Every sunrise you have ever witnessed, every beam of warmth on your face, every shaft of light filtering through a forest, exists because that balance has never been broken. The sun is not burning in the way a campfire burns. There is no flame, no oxygen. Instead, it is continuously converting hydrogen into helium, releasing astonishing amounts of energy in the process. Every second, the sun transforms hundreds of millions of tons of hydrogen into helium. A small fraction of that mass becomes pure energy, just as Einstein's famous equation predicts. That energy begins an extraordinary journey. Surprisingly, the light produced in the sun's core does not immediately escape into space. Far from it, inside the dense interior, a single photon may spend thousands, even hundreds of thousands of years being absorbed and re-emitted countless times before finally reaching the surface. Only then can it begin the final leg of its journey. Once free of the sun, sunlight races through space at nearly 300,000 kilometers every second. 8 minutes later, a tiny fraction of those photons reaches Earth. Some warm the oceans, some nourish forests, some are captured by green leaves, where plants transform sunlight into the energy that supports nearly every food chain on our planet. Even the food on our tables owes its existence to those ancient photons. In many ways, every meal is a gift from the sun. As the newborn sun settled into its long, steady life, another transformation was unfolding around it. The immense disk of gas and dust that had surrounded the young star was still spinning. Within that vast disk, microscopic grains gently collided. Most collisions ended quietly. Some particles bounced apart. Others clung together through tiny electrical forces. Grain by grain, pebble by pebble, the first building blocks of planets began to appear. It was an astonishingly slow process. Not days, not centuries, but millions of years. Nature has never been in a hurry. Over time, these growing clumps became larger and larger. Some reached the size of mountains. Others became worlds hundreds of kilometers across. Gravity once again took over. Larger bodies attracted smaller ones. Collisions became more frequent. Some were gentle enough to build. Others were violent enough to shatter entire young worlds. The solar system was anything but peaceful. It was a place of constant change, a place where countless worlds were competing for space around their newborn star. Among those countless collisions, one small world was slowly taking shape. It was still molten, still battered by impacts, still utterly lifeless. Yet within it lay the promise of oceans, continents, mountains, and one day, living creatures capable of asking where they had come from. That small world was Earth, and its story was only just beginning. Some begin quietly, hidden inside cold clouds of gas drifting through the darkness. Others are born in crowded nurseries where hundreds of young stars awaken together, illuminating the surrounding clouds with a soft blue glow. Though they may appear timeless from the perspective of a human life, every star is born, every star changes, and every star will one day reach its final chapter. Our own sun is no exception. Tonight, it rises and sets with comforting certainty, warming our oceans and lighting our skies just as it has for billions of years. It feels permanent, almost eternal. Yet even the sun is simply one traveler following the natural rhythm shared by every star in the universe. Long before the Earth existed, before the planets had taken shape, before even the first grains of dust circled our young sun, a vast cloud of gas slowly drifted through a quiet corner of the Milky Way. Over millions of years, gravity gently gathered this cloud together. Bit by bit, the cloud became denser, warmer, brighter, until deep within its heart, the pressure became so immense that the simplest element in the universe, hydrogen, began to transform into helium. In that silent moment, a new star was born. This remarkable process, known as nuclear fusion, has powered the sun ever since. Every second, hundreds of millions of tons of hydrogen are transformed into helium, releasing an astonishing amount of energy. That energy begins its long journey from the sun's core, slowly working its way outward before finally escaping into space as light and warmth. The sunlight that gently touches your face on a quiet morning began its journey deep inside the sun many thousands of years ago. Only after traveling through countless layers of glowing plasma did it finally race across the empty space between the sun and Earth, arriving here in just over 8 minutes. It is a quiet reminder that even light has its own long story. Stars spend most of their lives in this peaceful balance. Gravity constantly tries to pull them inward. Fusion gently pushes outward. For billions of years, these two forces exist in perfect harmony, allowing stars to shine steadily across the universe. Some stars are much smaller than our sun. They burn their fuel so slowly that they may continue shining for trillions of years, far longer than the universe has existed so far. Others are giants from the very beginning. These enormous stars live brilliant but surprisingly short lives. Their tremendous size allows them to burn through their fuel at an extraordinary rate, making them shine millions of times brighter than the sun. Yet their brilliance comes with a cost. While smaller stars patiently conserve their energy, massive stars spend it freely, living only a few million years before reaching the end of their journey. In the grand timeline of the cosmos, the brightest stars often have the shortest lives. As the night sky slowly turns overhead, it is comforting to remember that every point of light carries its own unique history. Some stars are only beginning their lives. Others have been shining quietly since long before our planet was born. And somewhere, far beyond our own galaxy, countless new stars are opening their eyes for the very first time, while others prepare to gently close theirs forever. The universe is never still. It is a place of endless beginnings, patient transformations, and graceful endings, unfolding slowly across the vast ocean of time. Nothing in the universe shines forever. Even the oldest and most faithful stars eventually reach a moment when the delicate balance they have maintained for billions of years begins to change. The hydrogen that once fueled their brilliant hearts slowly becomes scarce, and the quiet harmony between gravity and nuclear fusion gradually comes to an end. For a long while, nothing dramatic happens. The transformation is almost impossible to notice, unfolding over millions of years. If someone could watch the sun every day for an entire human lifetime, it would appear exactly the same. Even across thousands of generations, the changes would remain invisible. The universe is patient. It rarely rushes its greatest events. As hydrogen in a star's core is slowly exhausted, gravity begins to press inward once again. The core contracts, becoming hotter and denser than before. This rising temperature allows new forms of fusion to begin, while the star's outer layers expand gently outward. The once familiar star grows into a giant. Billions of years from now, our own sun will become what astronomers call a red giant. It will swell to hundreds of times its present size, glowing with a deep orange-red light that will transform the appearance of the inner solar system. Mercury will disappear. Venus will almost certainly be consumed. The Earth may survive the expansion, or it too may be engulfed by the sun's outer atmosphere. Even if it escapes, our planet will no longer resemble the blue world we know today. Its oceans will have long since evaporated. Its skies vanished into space, leaving behind a silent, lifeless landscape beneath an enormous crimson star. Yet this is not a tragedy. It is simply another chapter in the life of a star. After shedding its outer layers into space, the sun will reveal its small, incredibly dense core. This quiet remnant is called a white dwarf, though only about the size of Earth. A white dwarf contains nearly the entire mass of the original star. It no longer creates new energy through fusion. Instead, it slowly releases the heat stored during its long lifetime, cooling over billions upon billions of years. One day, unimaginably far in the future, it will become cold and dark, a silent ember drifting through space. Not every star ends so peacefully. The largest stars live faster, burn hotter, and meet far more dramatic endings. When these giants exhaust their fuel, gravity suddenly overwhelms them. Their enormous cores collapse in an instant, while powerful shock waves race outward through the star. For a brief moment, one dying star can outshine an entire galaxy. This extraordinary event is known as a supernova. Across the universe, these brilliant explosions scatter newly formed elements into space. Iron, gold, silver, calcium, oxygen, and countless other elements forged deep within stars are carried outward into giant clouds of gas and dust. Over millions of years, those clouds become the birthplace of new stars, new planets, and eventually, new life. The iron flowing through your blood, the calcium within your bones, the oxygen you breathe. Each was forged inside ancient stars that lived and died billions of years before the Earth was born. In a very real sense, every person carries a small piece of those forgotten suns. Their final gift became our beginning. As we look up at the quiet night sky, it becomes clear that the universe is not simply a collection of distant lights. It is a continuous cycle of endings becoming beginnings. Stars illuminate the darkness during their long lives. Then, in their final moments, they quietly prepare the universe for everything that comes next. Even in death, the stars continue creating the future. And perhaps there is something deeply comforting in that thought. Nothing in the universe is ever truly wasted. Every ending gently becomes the beginning of another story, continuing the endless rhythm that has shaped the cosmos since the very first stars awakened in the darkness. Our story now narrows to a single world, not the largest planet in the solar system, not the brightest, not the most massive, simply a small rocky planet orbiting an ordinary yellow star in one quiet corner of the Milky Way. Yet everything you have ever known, every mountain, every ocean, every birdsong at dawn, every forest, every heartbeat, would one day unfold upon this small world. But if you had visited the Earth in its earliest days, you would never have recognized it. There were no blue oceans, no green continents, no white clouds drifting lazily through the sky. There was no sky as we know it at all. The Earth was a world of fire. Its surface was covered by vast oceans of molten rock, glowing a deep orange beneath a sky thick with volcanic gases. Enormous volcanoes erupted almost constantly. Rivers of lava stretched across landscapes that had never known rain. The air was unbreathable, rich in carbon dioxide, water vapor, methane, and other gases released from deep within the young planet. There was almost no oxygen, no birds to fill the silence, no trees to sway in the wind, no wind at all in the familiar sense. Only heat, fire, and the steady rain of rocks from space. Astronomers call this early period the Hadean Eon, named after Hades, the ancient Greek underworld. It is an appropriate name. For nearly 600 million years, Earth was shaped by violence. Countless asteroids and comets still wandered the young solar system. Many crossed Earth's path. Some were no larger than houses. Others rivaled mountains. Each impact released enormous amounts of energy. Again and again, the young planet was battered. Its surface melted, then slowly cooled, only to melt once more beneath another collision. And yet, these impacts were not merely acts of destruction. Many scientists believe they also delivered precious ingredients, water locked within ancient minerals, simple organic molecules, perhaps even some of the chemical building blocks that would one day help life emerge. Nature has always had a remarkable way of creating opportunity from chaos. One impact, however, stood above all the others. Roughly 4.5 billion years ago, a young planetary body about the size of Mars crossed Earth's path. Today, scientists call this lost world Theia. The collision that followed was almost beyond imagination. The energy released exceeded anything humanity has ever witnessed. Entire regions of both worlds were vaporized. Molten rock was hurled thousands of kilometers into space. For a brief time, Earth may have been surrounded by a glowing ring of debris, not unlike the beautiful rings we admire around Saturn today. But this ring would not remain. Over the following weeks, months, perhaps years, gravity quietly gathered the scattered fragments. Piece by piece, rock by rock, they came together. From the ashes of one catastrophe, a companion was born. Our moon. Tonight, if you happen to glance upward before sleep finds you, you may see its gentle light watching over the Earth. It has accompanied every chapter of human history. It has inspired poets, guided sailors, marked the passing of months. Yet its own story began in one of the most violent moments our planet has ever experienced. Its presence would prove to be far more important than anyone once imagined. The moon's gravity would steady Earth's gentle wobble, helping to stabilize our climate over billions of years. It would raise the tides that stirred our ancient oceans. It would become a silent partner in the long story of life. Even catastrophe, it seems, can leave behind extraordinary gifts. As millions of years passed, the relentless bombardment slowly eased. The Earth began, ever so gradually, to cool. The glowing oceans of lava started to harden. The first thin crust formed across the planet's surface. Steam rising from countless volcanoes gathered high above the cooling world. Dark clouds began filling the sky, and before long, something happened that had never occurred anywhere on Earth before. It began to rain, not for hours, not for days, but for thousands, perhaps even millions, of years. The first oceans were about to appear, and with them, the stage upon which life itself would one day make its entrance. The Earth had changed. The relentless bombardment from space had begun to slow. The endless seas of molten rock no longer covered every corner of the planet. A fragile crust, thin and constantly shifting, spread across parts of the surface. It was still a dangerous world. Volcanoes towered above the landscape, pouring rivers of glowing lava across the young continents. The air remained thick with gases that no human could ever breathe. The sun shone faintly through a sky filled with ash and steam. Yet, for the first time, the planet was becoming calm enough for something remarkable to happen. Water, which had existed only as scorching vapor, began to cool. High above the Earth, clouds gathered. Not the soft white clouds we know today, but immense, dark oceans suspended in the sky. Then, the rain began. Imagine standing on that ancient world. There would be no birds singing, no rustling leaves, no crashing waves upon a sandy shore, only the deep rumble of distant volcanoes and the endless sound of rain. It fell across the entire planet, day after day, year after year, century after century. Some scientists believe this rainfall continued, almost without interruption, for hundreds of thousands of years. Others suggest it may have lasted even longer. The exact duration remains uncertain, but its effect is beyond question. Slowly, patiently, the first oceans began to fill. Water collected in great basins, carved by the cooling crust. Steam became rivers. Rivers became seas. Seas became oceans. For the first time in its history, Earth turned blue. If you could have viewed the young planet from space, you would have seen a world unlike any other we have encountered so far in our journey. Swirling clouds wrapped around immense dark oceans. Volcanoes pierced the surface here and there, releasing fresh gases into the atmosphere. The continents, if they existed at all, were small and constantly changing, reshaped by heat rising from the planet's restless interior. It was still a violent world, yet it was also becoming a beautiful one. The oceans transformed more than the landscape. They transformed the planet itself. Water became Earth's great storyteller, It carried minerals from rock into the sea. It absorbed heat from the sun during the day and released it slowly through the night, helping to soften extremes of temperature. It carved valleys, shaped coastlines, and quietly prepared an environment unlike any that had existed before. There was another mystery unfolding as well. The young sun was not as bright as it is today. Astronomers estimate it shone with only about 70% of its present luminosity. By all accounts, Earth should have been frozen. Its oceans should have remained locked beneath ice. Yet the geological evidence tells a different story. Liquid water was clearly present. The seas existed. Rivers flowed. How could this be? It is a puzzle scientists still study today. One likely answer lies in the atmosphere. The early Earth contained far greater amounts of greenhouse gases than it does now. Carbon dioxide, methane, water vapor. Together, these gases trapped heat escaping from the planet, creating a natural greenhouse effect strong enough to keep the oceans liquid despite the sun's relative faintness. It is another reminder that the Earth we know today did not simply appear. It evolved slowly, patiently, over immense spans of time. Every chapter prepared the next. As the rain continued to fall, the oceans grew deeper. Minerals dissolved into their waters. Lightning flashed through the ancient skies. Volcanoes released fresh chemicals from deep within the earth. The ingredients for something entirely new were gathering together. No living creature yet swam beneath the waves. No fish, no coral reefs, not even the simplest cell. And yet, the stage had finally been set. The oceans were waiting. The chemistry was waiting. The planet itself was waiting. Soon, somewhere within those warm ancient seas, matter would begin organizing itself in a way the universe had never seen before. For the first time, it would begin to live. For nearly 10 billion years, the universe had been a masterpiece of physics. Gravity gathered clouds into stars. Stars forged new elements. Galaxies slowly turned through the darkness. Planets were born from disks of dust surrounding young suns. Every event followed the quiet laws that had shaped the cosmos since its beginning. It was a universe of remarkable beauty, yet it was still missing something. Nothing observed, nothing remembered, nothing wondered. The stars shone because the laws of nature required them to. The oceans formed because gravity and chemistry allowed them to. The wind moved across the young earth without ever being felt. The waves rose and fell upon empty shores. The sunrise illuminated a world with no eyes to witness its beauty. For billions of years, the universe existed without a single living thing. Then, somewhere within the warm waters of the young earth, something changed forever. Unlike the birth of a star or the collision of galaxies, there was no brilliant flash announcing this moment. No explosion, no great cosmic event visible across the heavens. The greatest transformation in Earth's history may have begun so quietly that, had you been standing nearby, you would have noticed nothing at all. Perhaps it happened within a shallow tidal pool warmed by the sun, perhaps near deep-sea hydrothermal vents, where mineral-rich water surged upward from cracks in the ocean floor, perhaps somewhere entirely different. The truth is, we simply do not know, and that is one of the most honest and beautiful things science can say. Despite everything humanity has learned, despite microscopes capable of seeing individual molecules, despite laboratories recreating conditions from the early Earth, the exact birthplace of life remains one of nature's greatest mysteries. But while the location remains uncertain, the ingredients are becoming increasingly familiar. The young oceans contained water, carbon, hydrogen, nitrogen, phosphorus, sulfur, along with countless other elements forged long ago inside ancient stars. Lightning flashed through the atmosphere. Volcanoes released fresh gases into the sky. Ultraviolet light from the young sun poured down upon the oceans. Everywhere, chemistry was at work. Atoms joined together, separated, joined again. Millions upon millions of chemical reactions unfolded every second across the planet. Most led nowhere. Some created slightly more complex molecules. Those, too, often broke apart. Nature was experimenting, patiently, relentlessly, for hundreds of millions of years. Imagine scattering millions of tiny puzzle pieces across an enormous table. At first, they appear completely random, but given enough time, some begin fitting together. Then larger pieces emerge, not because anyone is guiding them, but because the laws of chemistry quietly favor certain arrangements over others. Many scientists believe something similar unfolded on the early Earth. Simple molecules gradually became more complex. Complex molecules began interacting. Some developed the remarkable ability to help create copies of themselves, not perfectly, but well enough to continue existing. This ability to make imperfect copies would change the universe forever, because every tiny imperfection became an opportunity, a chance for something new, a chance for nature to experiment over unimaginable spans of time. The most successful molecular arrangements persisted, while others quietly disappeared, long before there were cells, long before DNA, long before plants, animals, or people. The first whispers of evolution may already have begun. It is astonishing to think that every living thing on Earth, from towering redwood forests, to blue whales, to hummingbirds, to human beings, may trace its ancestry back to these humble chemical beginnings. The journey from chemistry to biology was almost certainly not sudden. It unfolded gradually, one tiny step at a time, one successful reaction leading quietly to another, one small victory repeated millions of times. And then, somewhere within those ancient waters, nature crossed an invisible threshold. For the first time in the history of the universe, matter was no longer simply following the laws of physics. It had begun to preserve information, to reproduce, to change, to evolve. The universe had spent billions of years creating stars. Now, for the first time, it had created something capable of becoming aware of those stars. The first true living cells were about to appear, and with them, the next great chapter of our story would begin. The first living cells did not resemble the life we know today. There were no forests reaching toward the sky, no fish swimming through the oceans, no flowers opening with the morning sun, no birds filling the air with song. The earth belonged entirely to creatures so small that billions could have rested upon the head of a pin. Yet these tiny organisms would become the ancestors of every living thing that has ever existed. The earliest cells were astonishingly simple. They possessed no eyes to see, no ears to hear, no brains to think. They had only one quiet purpose: to survive. They gathered energy from their surroundings. They repaired themselves when damaged, and when conditions allowed, they divided, creating copies of themselves. Not perfect copies. Tiny differences appeared from one generation to the next. Most changed very little. Some changes proved harmful and quickly disappeared. Others offered even the slightest advantage. Perhaps one cell gathered food a little more efficiently. Perhaps another endured warmer water. Perhaps another reproduced just a little faster than its neighbors. Over thousands of generations, these tiny advantages accumulated. Nature was not making conscious choices. There was no grand design, only countless small changes unfolding over immense stretches of time. Charles Darwin would one day describe this process as natural selection, but it had been shaping life for billions of years before humanity ever gave it a name. It is a wonderfully simple idea. Those organisms best suited to their surroundings tend to leave more descendants. Slowly, patiently, life changes, not in a single generation, but across millions of them. The result is the astonishing diversity we see today. Every feather, every leaf, every shell, every heartbeat, every pair of human eyes, all are chapters in a story that began with these humble, microscopic pioneers. For nearly 2 billion years, Earth belonged almost entirely to single-celled life. It is difficult for us to imagine such immense spans of time. If the entire history of Earth were compressed into a single 24-hour day, the first simple life would appear before dawn. Yet, for most of that imaginary day, nothing more complex would emerge. The oceans remained a microscopic world. Generation after generation of tiny organisms quietly transformed the planet. Among the most remarkable were ancient microbes known today as cyanobacteria. Unlike earlier life, these remarkable organisms discovered a new way to obtain energy. Instead of relying only upon chemicals dissolved in the water, they learned to capture sunlight itself. Using the energy of the sun, they transformed water and carbon dioxide into food. Today, we know this extraordinary process as photosynthesis. Almost as a side effect, these tiny cells released a gas into the atmosphere, oxygen. At first, that oxygen disappeared almost as quickly as it was produced. It reacted with iron dissolved in the oceans. forming vast deposits of iron oxide that still exist today. Some of the iron we mine for buildings, bridges, and railways began forming during this ancient chapter of Earth's history. For millions upon millions of years, the oceans quietly absorbed the oxygen. Then, something remarkable happened. The oceans could hold no more. Oxygen began accumulating in the atmosphere itself. To many of the earliest organisms, oxygen was poisonous. Countless ancient microbes disappeared. Yet for others, it became an extraordinary opportunity. Oxygen allowed cells to release far more energy from food than earlier forms of metabolism ever could. It was as though life had suddenly discovered a more powerful engine. This transformation is known as the Great Oxygenation Event. Although it unfolded over hundreds of millions of years, its consequences shaped every chapter that followed. Without it, there would be no animals, no forests, no dinosaurs, no mammals, no human beings. Sometimes the greatest revolutions arrive quietly, not in a single dramatic moment, but one tiny breath at a time. It is extraordinary to think that every breath you take tonight carries oxygen first released by distant descendants of these ancient microscopic pioneers. In a very real sense, the air filling your lungs is part of a story nearly 3.5 billion years old. Life had survived. Life had transformed the planet. And now, for the first time, the Earth was becoming ready for something even more remarkable. Not merely simple life, but complex life. Creatures built from countless cooperating cells. Creatures that would swim, walk, fly, and one day look back across the universe, searching for the story of their own beginnings. For billions of years, life continued its quiet work. Simple cells became more complex. Single organisms joined together, forming partnerships that would eventually become the first multicellular life. The oceans, once home only to microscopic organisms, slowly filled with creatures of astonishing variety. Soft-bodied animals drifted through ancient seas. Then came shells, fins, eyes. The history of life did not unfold as a smooth, uninterrupted journey. It was marked by triumph and tragedy. Entire worlds appeared, only to vanish again. Great extinctions reshaped the Earth more than once. Asteroids struck, volcanoes darkened the skies, continents drifted apart and collided once more. The climate swung between worlds of ice and worlds of warmth. Yet through every challenge, life endured, not because it was invincible, but because it was endlessly adaptable. Each generation inherited the successes of those before it, while quietly adding something new. Tiny changes accumulated across unimaginable spans of time. Fins slowly became limbs. Some creatures left the oceans and explored the land. Forests spread across the continents. Insects filled the skies. Reptiles grew to extraordinary sizes. For nearly 170 million years, dinosaurs ruled much of the Earth. If you had visited our planet then, you might have believed their reign would never end. But the universe has always reminded us that permanence is an illusion. 66 million years ago, a mountain-sized asteroid struck what is now the Yucatan Peninsula in Mexico. The impact released more energy than billions of nuclear weapons. Wildfires swept across continents. Dust and ash filled the atmosphere. Sunlight faded. The age of the dinosaurs came to an end. It was another great ending, and another unexpected beginning. With the great reptiles gone, small mammals that had long lived in their shadow began to flourish. Some returned to the seas. Some learned to fly. Others adapted to forests, grasslands, mountains, and deserts. Among them was one small lineage of curious primates. They climbed trees, worked together, learned from one another. Their hands became increasingly skillful. Their brains steadily grew larger. Over millions of years, one branch of that family would eventually walk upright across the African savanna. They shaped stone into tools. They mastered fire. They crossed rivers and mountains. They told stories beneath the stars. They became us. Compared with the age of the universe, humanity arrived only moments ago. If the entire history of the cosmos were compressed into a single calendar year, the Big Bang would occur just after midnight on January 1st. The Milky Way would form sometime in the spring. Our sun and Earth would not appear until early September. The dinosaurs would vanish on the evening of December 30th, and every chapter of recorded human history, every civilization, every empire, every invention, every poem ever written, every song ever sung, would occupy only the final few seconds before midnight on December 31st. We are astonishingly young, and yet, in those final seconds, something remarkable happened. The universe produced beings capable of asking where it had come from. Atoms that had once drifted through ancient stars assembled into brains capable of imagination. Molecules forged in forgotten supernova became minds capable of mathematics. Music, love, curiosity, and wonder. Perhaps that is one of the most beautiful ideas in all of science. The universe did not simply create life. Through life, it created a way to observe itself. Every time you look up into the night sky, the universe is, in a sense, looking back upon its own history. Every question you ask is another chapter in that ongoing conversation. And perhaps that conversation has only just begun. And so, here we are, after a journey spanning nearly 14 billion years. We have arrived at the present moment. A quiet evening, a comfortable chair, or perhaps a warm bed. A single human being listening beneath the same universe that has been unfolding since the beginning of time. When you pause to think about it, that is rather extraordinary. The atoms that make up your body have traveled an almost unimaginable path. The hydrogen in the water flowing through your veins was born in the first few minutes after the Big Bang. The carbon that forms your cells was forged inside a star that lived and died long before our sun existed. The calcium in your bones, the iron carried by your blood, the oxygen filling your lungs. Each began its journey in ancient stars, whose names we will never know. For billions of years, those atoms wandered. They drifted through galaxies, passed through clouds of interstellar dust, became part of new stars, new worlds, and eventually, part of you. Carl Sagan once said, "We are a way for the cosmos to know itself." It is a beautiful thought, not because it diminishes our importance, nor because it places us above the rest of nature, but because it reminds us that we have never truly been separate from the universe. We have always been part of its story. Sometimes it is easy to feel small beneath the night sky, to look upward at the countless stars, and wonder whether one human life could possibly matter. In one sense, we are small. Our planet is a tiny world orbiting an ordinary star. That star is one among hundreds of billions in the Milky Way. The Milky Way itself is only one galaxy among hundreds of billions in the observable universe. The numbers are almost impossible to comprehend, and yet there is another way to see it. The universe may be vast, but every great discovery it has ever revealed has been uncovered by minds no larger than our own. The same brain capable of appreciating a quiet sunset or smiling at a loved one is also capable of understanding galaxies billions of light years away. That, perhaps, is one of the greatest achievements of our species. We did not simply survive. We became curious. We built telescopes that could capture light older than our own planet. We placed spacecraft on distant worlds. We landed human beings upon the moon. We sent tiny robotic explorers beyond the edge of our solar system, carrying messages into the darkness for any future travelers who might one day find them. Every generation has inherited questions from the one before it, and every generation has added another small piece to humanity's understanding of the cosmos. There are still mysteries waiting. What existed before the Planck time? What is dark matter? What is dark energy? Are we alone among the stars? How will the universe ultimately end? These questions remain unanswered. If the universe has taught us anything during our journey, it is that nothing remains exactly as it is forever. Stars are born, galaxies slowly grow, planets take shape, life awakens, and then, with extraordinary patience, everything begins to change once again. Although the night sky above us appears timeless, it is only a single moment in an unimaginably long story. The universe is still young. At nearly 14 billion years old, it may sound ancient beyond comprehension. Yet compared to the future that still lies ahead, we are living remarkably early in cosmic history. Far more time remains than has already passed. Billions of years from now, the familiar constellations that humans have admired throughout history will no longer exist. The stars themselves are constantly moving, each following its own quiet path around the center of the Milky Way. Their motion is incredibly slow from our perspective, but over millions of years, the patterns begin to shift. The night sky of Earth's distant future would appear completely unfamiliar. Ancient navigators would lose their way. the stories attached to Orion, Cassiopeia, and the Big Dipper would belong only to history. Even the stars themselves continue their endless journeys through space. Meanwhile, our own galaxy is moving as well. Across the immense darkness separating galaxies, the Milky Way and our nearest large neighbor, the Andromeda Galaxy, are slowly drifting toward one another. Today, they remain separated by about 2.5 million light-years. It seems impossibly distant, yet gravity has been quietly drawing them together ever since they formed. Their meeting will not happen tomorrow, nor next year, nor even in the lifetime of our sun. It will take roughly 4 to 5 billion years before these two great spiral galaxies begin their graceful dance. Contrary to what the word collision might suggest, very few stars will actually strike one another. Space is simply too vast. Instead, the galaxies will slowly pass through each other like two gentle clouds of glowing light. Their spiral arms will stretch, twist, blend together. Over hundreds of millions of years, they will gradually merge into a single, enormous galaxy, unlike either one before. If humanity, or whatever follows humanity, is still here to witness it, the night sky would become breathtaking beyond imagination. Thousands of bright stars would appear where darkness once ruled. Great rivers of starlight would sweep across the heavens. Nebulae would glow with fresh colors as new generations of stars, ignited within clouds compressed by the merger. It would be one of the most magnificent sights the universe has ever offered. Yet even this spectacular event is only another step in an even longer story. After many billions more years, the supply of cold gas needed to create new stars will slowly begin to disappear. Each new generation of stars consumes part of the universe's remaining fuel. Little by little, the great stellar nurseries will grow quieter. Fewer stars will be born. The brilliant blue giants, so common in the universe's younger days, will become increasingly rare. The cosmos will not suddenly become dark. Instead, the change will be almost impossible to notice, like the final glow of a campfire slowly fading into warm embers. The universe will gently grow calmer with every passing age. For trillions upon trillions of years, the remaining stars will continue shining peacefully. But eventually, even the grandest age of starlight must come to an end. The universe that once blazed with countless newborn suns will become quieter, older, and infinitely more still. And yet, even in that distant future, the story will not be over. For beyond the fading light waits another chapter, one stranger, quieter, and more mysterious than anything that has come before. There will come a time when the universe no longer resembles the vibrant cosmos we know today. The brilliant spiral galaxies that decorate our night sky will have completed their graceful dances. Most of the stars that now shine so faithfully will have finished their long lives, leaving behind quiet remnants scattered across an ever-expanding universe. Yet time itself will continue. The universe never stops moving forward. It simply moves at a pace so vast that even billions of years become little more than brief moments in its endless history. Long after the final great galaxies have formed, new stars will become increasingly rare. The immense clouds of hydrogen that once gave birth to countless suns will slowly disappear, consumed over trillions of years by generations of stellar creation. Without fresh fuel, the universe will gradually lose its ability to create new light. The youngest stars will become older. The oldest stars will quietly fade. Eventually, only the smallest stars will remain. These tiny red stars, known as red dwarfs, are remarkable for their patience. They burn their fuel so slowly that some may continue shining for trillions of years, far longer than our own sun ever could. If the universe were a great symphony, these humble stars would be its final notes, lingering gently after every other instrument has fallen silent. For unimaginable ages, they will continue illuminating small pockets of darkness, but even they cannot shine forever. One by one, the last stars will exhaust their fuel. Their light will quietly disappear. Across the cosmos, entire galaxies will slowly become collections of faint stellar remnants, drifting through an ocean of darkness. White dwarfs, neutron stars, black holes, these ancient objects will remain long after ordinary stars have vanished. The universe will become quieter than it has ever been before, not because something terrible has happened, but because every story eventually reaches its peaceful conclusion. Even black holes, which often seem eternal, may not last forever. According to one of Stephen Hawking's most extraordinary ideas, black holes slowly lose tiny amounts of energy over unimaginable stretches of time through a process now called Hawking radiation. The change is so incredibly slow that no black hole has had enough time to disappear since the universe began. But given enough time, far more time than the current age of the universe, multiplied millions upon millions of times, even these great cosmic giants may gradually evaporate. Their immense darkness will quietly dissolve into faint particles, spreading across empty space. When the final black hole fades, the universe may enter its longest chapter, a universe without stars, without galaxies blazing with new life, without brilliant explosions lighting the heavens, only an immense, silent expanse where tiny particles drift farther and farther apart as space itself continues its gentle expansion. It is a future, sometimes called the heat death of the universe. Despite its dramatic name, it is not an explosion nor a catastrophe. It is simply a state of perfect stillness. Everything that can happen has already happened. Every star has shone. Every galaxy has evolved. Every great cosmic story has been told. And what remains is silence. There is something unexpectedly peaceful about this vision. Nature is full of cycles. A sunrise becomes sunset. Summer becomes winter. A seed becomes a tree before returning to the soil. The universe itself may follow a similar rhythm, though on a scale so immense that our minds can barely imagine it. Whether this quiet future is truly how the cosmos will end, no one can say with complete certainty. There may be discoveries waiting for future generations that change everything we believe today. Perhaps the universe holds another surprise. Perhaps another beginning hides beyond the ending. For now, these questions remain beautifully unanswered. As we drift through the vastness of time, we are reminded that the universe is not only a place of brilliant light and spectacular creation, it is also a place of extraordinary patience, a place where endings arrive not with sudden darkness, but with quiet grace, and somewhere far beyond the reach of our imagination, the last faint glow of the final star will gently disappear into the endless night, leaving behind a universe at perfect rest. As our journey through the universe begins to slow, it is worth pausing for a quiet thought. Throughout the billions of years we have explored together, we have watched stars ignite from clouds of gas, galaxies assemble across the darkness, planets emerge from swirling disks of dust, and life slowly awaken on one small world orbiting an ordinary star. It is easy to think of ourselves as observers standing outside this magnificent story. But we are not. We have been part of it from the very beginning. The atoms that make up your body are far older than the Earth itself, long before there were mountains, oceans, forests, or even our sun. Those atoms belonged to ancient stars that lived and died billions of years ago. The carbon in every living cell, the oxygen filling your lungs, the calcium strengthening your bones, the iron carried through your blood. Each was forged deep inside stars through the incredible process of nuclear fusion. The earliest universe knew only a few simple elements: hydrogen, helium, a trace of lithium. Everything else had yet to exist. The elements needed to build planets, oceans, and living creatures had not yet been created. It was the stars that changed everything. For millions and billions of years, generation after generation of stars quietly worked like cosmic furnaces. Within their brilliant cores, simple atoms combined into heavier ones. When these stars finally reached the ends of their lives, many scattered their newly created elements back into space. Those clouds drifted through the galaxy, mixing with gas left behind by countless other stars. Eventually, gravity gathered these enriched clouds together once again. From them, new stars were born. Around some of those stars, new planets slowly formed. One of those planets became Earth. Every tree, every bird, every mountain, every ocean, and every human being is built from material recycled across countless generations of stars. In many ways, the universe has never stopped recycling itself. Nothing is truly separate. The atoms that once belonged to distant suns became part of ancient oceans. Those oceans gave rise to life. Life transformed the atmosphere. Generations came and went. And today, some of those same atoms allow you to read these very words. It is a remarkable chain, stretching across nearly 14 billion years. Sometimes we imagine ourselves as small and insignificant beneath the vastness of the night sky. The universe certainly makes us feel tiny. Our planet circles an ordinary star among hundreds of billions inside one galaxy. That galaxy is itself only one among hundreds of billions, more scattered across the observable universe. The numbers are almost impossible to comprehend, yet size alone does not determine significance. A single page may be tiny compared to an entire library. Still, without each page, the story could never exist. Humanity occupies only a small corner of the cosmos. But in this quiet corner, something extraordinary has happened. After billions of years of cosmic evolution, the universe has produced beings capable of wondering about its own existence. We look upward and ask questions. We search. We learn. We dream. In a way, when we study the stars, the universe is gently learning about itself. That thought has comforted generations of scientists, philosophers, and dreamers alike. Perhaps we are not separate from the cosmos after all. Perhaps we are simply one small expression of it, a collection of ancient stardust that has, for a brief and beautiful moment, become aware of the endless sky from which it came. As evening falls and the stars quietly emerge overhead, it is easy to feel very small. A single person standing beneath the night sky occupies only a tiny place upon a small planet. That planet circles an ordinary star, itself only one among hundreds of billions within the Milky Way. Beyond our galaxy lie countless others, stretching farther than any human being could ever travel. The scale is almost beyond imagination. And yet, perhaps feeling small is not something to fear. The ocean is made of countless tiny drops of water. A forest is made of individual leaves. A galaxy is built from billions of stars. Sometimes the greatest things in existence are simply collections of countless small parts working together. Earth is one of those small parts. From space, our world appears as nothing more than a pale blue sphere, wrapped in a thin blanket of clouds. There are no borders visible from orbit, no cities glowing in daylight, no signs of the countless lives unfolding every second. Only one small world, quietly drifting through the darkness. For billions of years, Earth has faithfully traveled around the sun, completing the same gentle journey over and over again. During that time, continents have drifted across its surface. Mountains have risen before slowly wearing away. Oceans have opened and closed. Entire species have appeared, flourished, and quietly disappeared into history. Life itself has never stood still. Every creature that has ever lived belongs to an unbroken chain stretching back through time. The first fish, the first forests, the great dinosaurs, tiny mammals hiding beneath ancient trees, the earliest humans gathering around fire, beneath unfamiliar stars. Each generation inherited the world from the one before it, adding its own small chapter to a story billions of years in the making. Now that story belongs to us. For a brief moment in cosmic history, humanity has become capable of understanding where it came from. We have built telescopes powerful enough to see galaxies whose light began its journey before the Earth even existed. We have walked upon the moon, sent machines beyond the edge of our solar system, landed robotic explorers on distant planets, listened to the faint echoes left behind by the birth of the universe itself. Every discovery has been another quiet step forward, not toward conquering the universe, but toward understanding it. Perhaps that is the greatest adventure humanity has ever undertaken, not one of speed or distance, but one of curiosity. every child who has looked up and wondered what the stars are made of, every scientist who has spent years searching for answers, every explorer who has dared to sail beyond the known horizon has shared the same simple desire to understand. The universe has never demanded that we solve all of its mysteries. Instead, it seems content to reveal them one by one, rewarding patience more than certainty. Even today, after centuries of remarkable discoveries, we know that our understanding remains incomplete. There are galaxies we have never seen, worlds we will never visit, questions that may remain unanswered for generations still to come. And perhaps that is exactly as it should be. A universe without mystery would be far less beautiful. Wonder exists because there is always another horizon waiting beyond the one we can see. So the next time you look upward into the quiet night, remember that you are not simply observing the universe from afar. You are part of it. Every heartbeat, every breath, every thought is carried by atoms that have traveled through stars, across galaxies, and through billions of years before becoming part of you. The distance between yourself and the cosmos is not measured in light years. It is measured only by perspective, because in the end, we have never truly been visitors in the universe. We have always been home. As our journey through the universe nears its end, we arrive at a place unlike any we have visited before. Not a distant galaxy, not a black hole, not the heart of a blazing star. Instead, we arrive at the edge of what humanity currently knows. For all the remarkable discoveries made over thousands of years, science has never claimed to possess every answer. In fact, the deeper we explore the universe, the more we discover how many beautiful mysteries still remain. There is something comforting about that. Imagine standing on the shore of a vast ocean just after sunset. The gentle waves stretch toward the horizon until they disappear into darkness. You can see only a small portion of the sea before you, while the rest remains hidden beyond the night. The universe is much the same. Every discovery is another step along the shoreline. Yet the ocean of the unknown continues far beyond our sight. Perhaps the greatest mystery of all is the simplest question imaginable. Why is there a universe at all? We have learned an extraordinary amount about what happened after the Big Bang. We understand how space expanded, how atoms formed, how stars ignited, and how galaxies slowly gathered across billions of years. But what caused the Big Bang itself? No one knows. Some scientists believe it marked the true beginning of space and time. Others wonder whether our universe emerged from an earlier universe, part of an endless cycle of beginnings and endings stretching beyond imagination. Still others suggest that countless universes may exist, each with different laws of nature, while ours is simply one among an infinite collection. These ideas remain fascinating possibilities. But for now, they remain possibilities. Science is careful. It asks questions boldly, but accepts answers only when supported by evidence. And so, the beginning of everything remains one of humanity's greatest unsolved puzzles. Another mystery surrounds something we have already encountered during our journey: dark matter. We know it is there because of its gravity. We see galaxies behaving as though invisible mass surrounds them. We observe giant clusters held together by something hidden from our eyes. Yet, despite decades of careful searching, no one has directly detected a single particle of dark matter. Around the world, enormous laboratories have been built deep beneath mountains, shielded from cosmic radiation, patiently waiting for the faintest sign of these invisible particles. So far, the universe has remained silent. Dark energy presents an even greater mystery. It appears to make up most of the cosmos, quietly causing the expansion of space to accelerate. Yet no one fully understands what it truly is. It fills the universe, shapes its future, and remains almost completely unknown. Imagine living beside the ocean your entire life without understanding what water is. That is, in many ways, where humanity finds itself today, surrounded by mysteries so vast that we can barely describe them. And perhaps that is not a sign of failure. Perhaps it is a sign that discovery is far from over. Every generation inherits questions from the one before it. Some are answered, others patiently wait for curious minds yet to be born. The greatest discoveries of tomorrow may already exist quietly among the stars, waiting for someone to ask the right question. For thousands of years, people have looked toward the night sky, searching for certainty. Ancient civilizations traced patterns among the stars and built stories around them. Sailors crossed vast oceans by their light. Philosophers wondered whether the heavens were perfect and eternal. Scientists later discovered that the stars themselves were distant suns, each with its own history stretching across billions of years. With every generation, humanity believed it had reached another great milestone of understanding. And with every generation, the universe quietly revealed another mystery, waiting just beyond the horizon. Perhaps that is the true nature of knowledge. The farther we travel, the farther the horizon seems to move. Today, astronomers can observe galaxies whose light has traveled for more than 13 billion years before reaching Earth. Powerful telescopes allow us to peer deeper into space than any previous generation could have imagined. Yet there is still a limit. Beyond a certain distance lies the edge of the observable universe. This is not the edge of existence itself. It is simply the greatest distance from which light has had enough time to reach us since the universe began. What lies beyond that invisible boundary? No one knows. There may be countless more galaxies stretching endlessly into space. The universe itself may continue forever, or perhaps it has a shape and size we have yet to understand. For now, the answer remains hidden beyond our view. There is another question that has quietly followed humanity for centuries. Are we alone? The universe contains hundreds of billions of galaxies. Each galaxy holds hundreds of billions of stars. Around many of those stars orbit planets. And among those planets are surely worlds unlike anything we have ever seen. Some may be frozen beneath endless sheets of ice. Others may glow beneath multiple suns. Some may possess oceans deeper than mountains are tall. A few may even have the gentle conditions needed for life. So far, however, Earth remains the only place where life is known to exist. No signal has confirmed another civilization. No visitor has crossed the stars to greet us. The silence of the cosmos has become one of its greatest mysteries. Perhaps intelligent life is incredibly rare. Perhaps civilizations are separated by distances so immense that they never meet. Or perhaps the universe is simply waiting for the right moment. For now, we can only wonder. There are mysteries even closer to home. What truly happens inside a black hole? Can gravity and quantum physics one day be united into a single elegant theory? Will humanity discover new laws of nature that completely reshape our understanding of reality? History suggests that the universe still has many surprises waiting. Only a little more than 100 years ago, we did not know that other galaxies existed beyond the Milky Way. Less than a century ago, we had never seen a planet orbiting another star. Today, thousands of distant worlds have already been discovered. What seems impossible today may become ordinary tomorrow. That is the quiet beauty of science. It is never finished. It does not seek perfection. Instead, it moves gently forward, one observation, one question, and one discovery at a time. And perhaps that is the greatest lesson the universe offers us. Not that we should fear the unknown, but that we should welcome it. Because mystery is not the opposite of knowledge. It is the beginning of it. Every answer humanity has ever found began as a question. Someone dared to ask beneath the same night sky that stretches above us today. As our journey draws toward its final chapter, we leave behind certainty and carry with us something far more valuable, a sense of wonder, the kind of wonder that reminds us the universe is still writing its story, and that somewhere beyond the edge of what we know, another discovery is already waiting patiently to be found. Our journey began in complete darkness, before there were stars to light the heavens, before there were galaxies drifting across the cosmos, before planets, oceans, mountains, or life itself. There was only the quiet beginning of space and time. From that single moment, the universe slowly unfolded, not all at once, not in haste, but with extraordinary patience. Over billions of years, tiny particles became atoms. Atoms gathered into clouds. Clouds became stars. Stars gathered into galaxies. Within those galaxies, new stars were born, each surrounded by swirling disks of dust from which planets slowly emerged. On one small planet, orbiting one ordinary star, something remarkable happened. The universe became aware. Life opened its eyes. The first simple cells drifted through ancient oceans. Those tiny beginnings slowly transformed into forests, coral reefs, insects, fish, dinosaurs, birds, mammals, and eventually into people who would one day look upward and ask perhaps the oldest question of all: how did all of this begin? It is a question that has echoed through human history for thousands of years. Every civilization has looked toward the sky with curiosity. Every generation has searched for its own answers. Today, our telescopes reach farther than ever before. Our spacecraft have wandered beyond the planets. Our instruments can detect light that that has traveled almost the entire age of the universe. Yet despite everything we have learned, the feeling of wonder remains exactly the same. Perhaps it always will. There is something beautifully humbling about realizing that the universe does not exist for us. The stars were shining billions of years before the Earth formed. They will continue their quiet journeys long after our own chapter has ended. And somehow, rather than making our lives feel smaller, that thought makes them feel more meaningful. Because every moment becomes precious. Every sunrise, every quiet evening beneath the stars, every conversation shared beneath a clear night sky, each exists only because an unbroken chain of events, stretching back nearly 14 billion years, unfolded exactly as it did. The universe did not rush to create this moment. It took almost all of cosmic history. Sometimes we think of ourselves as separate from nature, separate from the stars, separate from the universe itself. But throughout our journey, another truth has quietly emerged. We have never been separate. Every breath contains atoms forged inside ancient stars. Every heartbeat is powered by elements created long before the Earth existed. Even the calcium in our bones and the iron flowing through our blood began their journey inside suns that disappeared billions of years ago. The universe is not simply around us. It is within us. Perhaps that is why looking at the night sky often feels strangely familiar. Some small part of us recognizes home, not as a place, but as a story that began before time itself, a story still unfolding with every passing second, and a story that, in ways both great and small, each of us continues to carry forward simply by existing. Tonight, as the stars quietly continue their endless dance above, it is comforting to remember that we have never been spectators watching the universe from the outside. We have always been part of its story, from the very first light to this very moment. And so, our journey slowly comes to its end. We have traveled farther than any ship could ever sail, farther than any spacecraft has yet ventured. Together, we have crossed billions of years, witnessed the birth of the first light, watched galaxies gather from quiet clouds of gas, followed the lives of stars, stood beside the formation of worlds, and reflected upon our own small place within this extraordinary universe. Now, all that remains is to simply look upward one last time. The night sky has always been humanity's oldest companion, long before cities glowed with electric lights, before maps, books, or telescopes. Our ancestors rested beneath these same stars. They wondered what those distant lights might be. They imagined stories among the constellations and searched for meaning in the endless darkness above. Although our understanding has changed, the feeling has not. Even today, standing beneath a clear sky can fill us with the same quiet sense of awe that people experienced thousands of years ago. Perhaps that feeling is timeless. The universe asks nothing of us. It does not hurry. It does not judge. It simply exists, following its gentle rhythms across spans of time so vast that entire civilizations rise and fall in what, to the cosmos, is only the briefest moment. There is something deeply peaceful about that thought. Tomorrow, the Earth will continue its silent journey around the sun, just as it has for more than 4.5 billion years. The moon will quietly circle our world. The planets will continue their graceful paths through the solar system. Far beyond them, the Milky Way will slowly turn, carrying every one of its hundreds of billions of stars around its hidden center. And beyond even our galaxy, countless others will continue drifting through the expanding universe, each following a story entirely its own. The cosmos has never stopped moving. It never will. Even as you close your eyes tonight, stars are being born in distant clouds of gas. Somewhere, a planet is completing another orbit around its star. A black hole quietly bends the light of a passing galaxy. Two galaxies begin a dance that will last hundreds of millions of years. And somewhere unimaginably far away, light has just begun a journey that may not reach another world for billions of years. The universe is alive with quiet motion, not hurried, not chaotic, simply patient. Perhaps there is something we can learn from that patience. We often spend our lives rushing from one moment to the next, worrying about tomorrow, or holding tightly to yesterday. The universe does neither. It unfolds exactly as it must, one moment following another, never rushing its own story. Maybe we can allow ourselves to do the same, to breathe a little more slowly, to appreciate the ordinary miracles that surround us every day. The warmth of sunlight, the sound of rain, the quiet company of those we love, the simple privilege of looking up and knowing that we are part of something unimaginably vast. As we say goodnight to the cosmos, remember that this was never just the story of stars or galaxies. It was also your story. Every atom within you has traveled across billions of years to arrive here. Every heartbeat is connected to events that began long before the Earth existed. You are, quite literally, one small chapter in a story that began nearly 14 billion years ago. And although our journey together ends here, the universe continues writing its next chapter. It will still be there tomorrow night, and the night after that, patiently waiting, just as it always has. So, as sleep gently finds you, let your thoughts drift peacefully among the stars. The universe will keep its quiet watch until morning. Good night, and thank you for sharing this journey through the endless cosmos.